Hello students, welcome to SS classes. In previous lecture, we learned about the indicators, their color changes with acids and bases and physical properties of acids and bases. Apart from that, the difference between weak acid and strong acid, weak bases and strong bases we learn. Let us start with the chemical properties of acids in detail. So here is the first property of acids where the acid react with metal. So when acid react with metal, forms salt and produce hydrogen gas. So first property of acid is reaction of acid with metal. So when metal react with the acids, the reaction produce salt and hydrogen gases evolve. Now how one can confirm the evolution of hydrogen gas? The gas evolve is burns with a popping sound. If the gas burns with a popping sound, then we can say the gas evolve is hydrogen. Because burning with a popping sound is the characteristic property of hydrogen gas. So for example, when metal zinc react with dilute HCl. When it react with dilute HCl, it produces the zinc chloride and hydrogen gas is getting evolved in this chemical reaction. This gas is a colorless and odorless gas. But if we bring the burning mastic or burning candle near the mouth of test tube, the gas burns with popping sound. Hence we can conclude that the gas evolve is hydrogen. Another example is reaction of metal zinc with sulfuric acid. When zinc metal react with the sulfuric acid, the hydrogen gases evolve and then the sulfate react with the zinc, so it forms the zinc sulfate. So you can write many examples over here, the different metals and different acids. But there are certain limitations with the reaction of metal with the nitric acid. When nitric acid reacts with the metal, it produces the oxides of nitrogen. In this reaction, apart from producing the hydrogen, the water is evolved. That we are going to learn in third chapter of chemistry. But here you should know about with not all metals, nitric acid produces hydrogen gas. So that we are going to discuss in detail in the third chapter of the chemistry, that is metals and non-metals. Here we have taken one weak acid, that is acetic acid, which is also called as ethanoic acid. Chemical formula CH3COOH. When it reacts with the metal zinc, it forms zinc acetate. It produces zinc acetate and hydrogen gases evolve in this chemical reaction. Here are some more examples of reaction of metal with acid. For example, sodium will react with the acid HCl, it gives sodium chloride and hydrogen gases evolve. Ferrous, when ferrous react with the hydrochloric acid, it gives ferrous chloride and hydrogen gases evolve. When magnesium react with the sulfuric acid, it gives magnesium sulfate and H2 is evolved. For example, aluminium, when aluminium react with the sulfuric acid, it forms aluminium sulfate and hydrogen gases evolve. So a lot of examples are there where you can write the chemical reaction between the acids and the metals. Now children, here is the activity shown where the reaction of metal takes place with acid. So for example, here we have taken the test tube containing dilute sulfuric acid and some zinc granules. This reaction we have already done in the first chapter of chemistry, and we know that when the metal react with the acid, like zinc react with the acid, the bubbles of hydrogen gas are formed in the reaction mixture. And this gas is getting evolved by this delivery tube. If this delivery tube is insert in a soap solution, you will observe that the bubble formation takes place, the soap bubble formation takes place inside it, the hydrogen gas is there. If you bring the burning candle or burning mastic near to this gas bubbles, you will observe that this bubble burns with a popping sound because of the hydrogen burns with the popping sound over here. So you can draw this activity diagram in order to show the reaction of metal with acid. The second reaction is reaction between acids and bases. The reaction of acid with base. Base means metal hydroxides. So this reaction is also known as neutralization type of reaction, where the acids and bases neutralizes the effect of each other. Why this reaction is called neutralization type of reaction? Because neutralization means neutralizing the effect of one another. So in this chemical reaction, the acid neutralizes the effect of base and base neutralizes the effect of acid. So that's why the reaction is called neutralization type of reaction. A special type of reaction of double displacement kind of reaction, where the acid reacts with the bases and neutralizes each other. The equation can be represented as the acids when it reacts with the bases, then it forms salts and water. And nature of the salt is depend on nature of acid and bases. Here one example is given where the strong acid like HCl reacts with a strong base, that is NaOH. So when HCl reacts with the NaOH, which is a kind of double displacement reaction, where we are going to change the place of cations and anions. So for example, here H plus is the cation and Na plus is again the cation. So exchange their place, what you will get? You will get H2O and NaCl. So in this reaction, the nature of the salt form is neutral, because the acid is the strong acid and base is again the strong base. So when strong acid react with the strong bases, the salt form have the neutral nature. So here just remember what is reaction between acid and bases. When acid and base react with each other, form salt and water. Here you can take many examples of acid and bases and try to obtain the product form in this type of reaction. So many acids you can take over here, many bases you can take over here, and observe that what kind of salt will form in this type of reaction. So one more example is given over here apart from the reaction between HCl and NaOH. So for example, H2SO4 sulfuric acid, when it reacts with the another strong base, that is potassium hydroxide. So when H2SO4 reacts with the KOH, it forms K2SO4. It forms the salt potassium sulfate and water is produced in this type of reaction. Now here the nature of acid is again strong acid and nature of the base is again strong base. So when strong acid react with the strong bases, type of salt is neutral in nature. So the nature of K2SO4 potassium sulfate is neutral in nature. Now children, here you can see when strong acid reacts with strong bases, the type of salt form will be neutral. So here example of given, that is NaOH and HCl gives NaCl and H2O. Now, so for example, we are carrying out the reaction between strong acid and weak base. Okay, strong acid and weak base. Now here, which substance is weak in nature? That is the base. And which substance is strong in nature? That is acid. So who is strong one? Acid is the strong one. So whatever the salt will form, that will have the nature of strong substance. It means the strong is the acid. So nature of the salt will be acidic. So for example here, acid is strong and base is weak. So here we have taken example of strong acid, that is HCl, and the weak base we have taken NH4OH, that is ammonium hydroxide. So type of salt will form in this reaction, that salt will have the acidic nature, because what is strong over here? Acid is the strong. So nature of the salt will be acidic. So here in this case the type of salt form, that is NH4Cl, that is ammonium chloride. So how it forms? Yes, of course, the type of reaction is double displacement. So let us exchange the place of cations and anions. So NH4 will come to the place of H. H will go to the place of NH4Cl. So product form will be NH4Cl and H2O. So nature of the salt is acidic, because what is strong? Acid is the strong. So nature of the salt will be acidic. Okay. Now here. Now in this case we have taken acid weak and base strong. If the base is strong and the acid is weak, so nature of the salt will be basic, of course, because what is strong over here now in this case? Base is the strong, so nature of salt will be basic in nature. So one of the example here we have taken, that is weak acid CH3COOH, that is the acetic acid, which is a weak acid, and strong base we have taken, that is KOH. Carry out double displacement reaction, so you will get water over here, H will come here, Na will go there, so that will form CH3COONA. So that is sodium acetate. Sodium acetate is the basic salt. Fine. Now here in this case we have taken both substances which are weak, that is weak acid and weak bases. When both are weak, acid is again weak and base is again weak. None of the substance in acid and bases is strong. So when acid is the weak and when base is the weak, this type of salt will form that will have, of course, the neutral nature. In this case, when both are strong, nature of the salt will be neutral. When both are weak, nature of the salt will be again neutral. For example, weak acid here we have taken CH3COOH, and weak base we have taken NH4OH. So salt form will be CH3COO, that is NH4. It means ammonium acetate. Its name is ammonium acetate, and water will form. So nature of the acid and base determines the nature of the salt form in the neutralization type of reaction. Now we are going to learn the reaction, the second reaction. Is it second? No, it's third reaction. First reaction we have learned, that is reaction of acid with metal. Second we have learned reaction of acid with metal hydroxide, that is bases. And third reaction that we are going to learn is the reaction between acid and metal oxide. In this case, not metal alone over here, it is in a combined form with the oxide. So metal oxide with acid. Let us see what will form. Now when metal oxide when react with the HCl, it forms salt and it ultimately forms water. The same products are formed as the product formed when acid react with bases. So when acid react with metal oxide, the salt and water are formed. So here Na2O, sodium oxide, when it react with metal, with acid HCl, it gives salt NaCl and form water. This is again a kind of double displacement reaction. So here you will get the salt, it is NaCl, and water will form. Let us carry out reaction between another metal oxide, is magnesium oxide metal and acid HCl. So let us carry out double displacement reaction and we'll see what product will form. So Mg will come to the place of H, H will go to the place of Mg. So product form will be MgCl2, magnesium chloride will form, and water is again one of the product in this reaction. Third reaction is with the copper oxide metal and with the acid HCl. Let us see what will form. Copper will come to the place of H, H will go to the place of copper. So product form are copper chloride and water is formed in this reaction. So when acid reacts with a metal oxide, salts and water are formed, which is again a double displacement, or we can say neutralization type of reaction. So this is the third reaction, which is the third chemical property of acid. Our next fourth property is reaction of acid. We are learning the reaction of acid. First we have learned reaction of acid with metal. In second type we learned reaction of acid with metal hydroxide, that is bases. Third reaction we learned, that is reaction of acid with metal oxide. Now the fourth reaction is the reaction of acid with metal carbonates and metal bicarbonates. This is carbonate CO3 and HCO3 is bicarbonate, which is also called as hydrogen carbonate. So this is again one of the neutralization type of reaction when acid react with the metal carbonates and bicarbonates form salts and water. But apart from salt and water, this chemical reaction produce one more product, that is carbon dioxide. So when acid HCl, it reacts with the sodium carbonate. Sodium carbonates, the salt form will be sodium chloride, hydrogen will form, and apart from that CO2 is evolved in this type of chemical reaction. The same products are formed when acid react with metal bicarbonates. NaCl, water and carbon dioxide. So children, one more example is here of a reaction of acid with metal carbonate, that is aluminium carbonate. Aluminium carbonate will react with the acid HCl. So what do you think what product will form over here? It will form aluminium chloride and water will form and CO2 is evolved. Aluminium chloride will form, water will form and carbon dioxide is evolved. So what is our conclusion? Our conclusion is when acid reacts with metal carbonates or metal bicarbonates, salt is formed, water is formed and carbon dioxide is evolved. Now children, how one can confirm that the evolved gas is carbon dioxide? There are certain properties by which one can come to know that the gas evolved in this reaction is carbon dioxide. First, carbon dioxide is colorless and odorless gas. Hydrogen is also colorless and odorless gas. So you will get confused whether the evolved gas is a carbon dioxide or hydrogen. But we know that hydrogen burns with a popping sound. In the same way, carbon dioxide extinguishes fire. Is not combustible gas, rather it extinguishes fire. So if the gas evolved is colorless, odorless, and if it extinguishes the fire, then the evolved gas is carbon dioxide gas. Second property, when this gas is passed through lime water, then the lime water color changes from colorless to milky white. The same activity we learn in biology chapter, that is life processes in topic respiration. So if you take lime water and the CO2 is dissolved in that, then the color of lime water changes from colorless to milky white. So here is the activity where in one of the test tube we have taken sodium carbonate. Here we have taken sodium carbonate and we have added the dilute hydrochloric acid. So when sodium carbonate reacts with dilute hydrochloric acid, it will form NaCl, water and carbon dioxide is evolved. So when this carbon dioxide is passed through delivery tube into the test tube containing calcium hydroxide solution. Calcium hydroxide solution is nothing but the lime water. So when the CO2 is passed through this lime water, color of lime water changes from colorless to milky white. And this reaction, this color changes takes place because in this reaction the calcium carbonate is formed. When carbon dioxide reacts with calcium hydroxide, that is lime water, then the product form is calcium carbonate. If limited CO2 is passed, listen carefully, if limited CO2 is passed, then color changes from colorless to milky white due to synthesis of calcium carbonate, which is not soluble in water. So afterwards it precipitates out at the bottom of the test tube. But if we keep on passing the CO2, it means when excess CO2 is passed through lime water, then later on the milky white color of lime water disappears again. Means again the milky white color changes to colorless. This color disappears due to synthesis of calcium bicarbonate. When the limited CO2 is passed through lime water, then color changes from colorless to milky white. And when excess CO2 is passed, then this milky white color disappears because the calcium carbonate then later on changes to calcium bicarbonate, and due to this the color disappears, the milky white color disappears. So children, this is about the type of chemical reactions of acids. So let us recall the properties of acid once again. In physical property, we learn that acids are sour in taste. Acid changes color of blue litmus to red. Acid solution conduct electricity, and pure acids does not conduct electricity. Later on, we learn that the chemical properties of acids, that is reaction of acid with metal, reaction of acid with metal oxide, reaction of acid with metal hydroxide, that is bases, reaction of metal with metal carbonates and metal bicarbonates. Now here is the reaction of bases. Let us discuss the chemical properties of bases in detail. So, when bases reacts with a metal, the first property of reaction of base is reaction of base with metal. As we have learned, the first property of acid is reaction of acid with metal. In the same way, reaction of base with metal. But one thing that you have to note here is not all metals reacts with bases. So there are limitations. So one of the example is given over here, that is the reaction of zinc with metal sodium hydroxide. So when zinc react with base, that is sodium hydroxide, hydrogen gases evolve. In the same way as acid reacts with the metal, hydrogen gases evolve. In the same way as bases reacts with the metal, hydrogen gases evolve. And in this case, the product form, the salt form is the sodium zincate, that is Na2ZnO2, that is sodium zincate. So first property of bases is same as like the first property of acids. When acid react with the metal, form salt and hydrogen. In the same way, when bases react with the metal, form salt and hydrogen gases evolved. Second property of base is reaction of base with acid, that we have already learned in the chemical properties of acid. It is reaction of acid with bases. So acid with bases is the same property, that is reaction of base with acid. So in this reaction, when bases react with acids, salt and water are formed. And this reaction is known as neutralization type of reaction. So this is all over about the chemical properties of acids and bases. What are those properties? Reaction of acid first, acid with metal oxide, acid with metal hydroxide, acid with metal carbonates and bicarbonates. So these are the 5 chemical properties of acids. But bases have only 2 to 3 chemical properties, that is reaction of base with metal. Second is reaction of base with acid. And third reaction is reaction of base with non-metal oxides. That we are going to learn right now. Now children, third reaction is the reaction between base and non-metal oxide. So for example, reaction between base sodium hydroxide, that is NaOH, when it reacts with a non-metal oxide such as carbon dioxide or nitrogen dioxide. So let us take carbon dioxide. When NaOH base react with non-metal oxide, that is carbon dioxide. So in this reaction, again this salt and water are formed. As acid reacts with metal oxide, in the same way bases reacts with non-metal oxide, and both the reaction produces salt and water. So if you write the chemical reaction between base NaOH plus non-metal oxide, that is carbon dioxide CO2, it gives products Na2CO3, that is sodium carbonate as a salt, and water is formed in this reaction. That is, when bases reacts with non-metal oxide, it produces salt and water. So which is again one of the neutralization type of reaction, where the non-metal oxides act as acidic in nature, and bases, that is NaOH, is the alkaline in nature. Thank you. This is all about the today's lecture.